This is basically a cluster of Docker machines. What is a cluster? Cluster is a collection of 2 or more nodes or machines or servers, right? So what is the use of cluster? Cluster is basically for high availability, right? And reliability, right? And failover. What is this high availability, right? So let us say you're using mobile, you're using one of the operators, right? So Vodafone or Airtel or anything, right? So what they promise is 99.999% high availability. What is this high availability? So it's like less than 5 minutes downtime in a year. Right? So a typical thing like this, like let us say you're using a mobile, right? So when you call someone, the mobile goes through various phases. The signal goes through various stages, right? Something like it first goes to the base station, then from there it goes to MSC, and there is something called HLR, VLR, and then it goes to the tower, and from that tower it goes to the other mobile which you are calling, right? So there is a lot of internal things which goes through when a mobile call is routed from one mobile handset to other mobile handset, right? So typically in the base station, in the MSC, so there will be a lot of servers, high-end servers, which will be processing calls, right? And there will be a software running on them, right? So either Linux or Solaris or any operating system will be running on it. And there is a middleware, which is a kind of software which is responsible for the high availability. So what happens is if one of the machine goes down, the other will come up automatically. And let us say suddenly there are some natural calamity like floods or earthquake in one area, right? So suddenly the network will not go down because the calls will be routed by other data center, because there will be something like a cluster created geographically. So let us say one server is in Hyderabad, the other server is in Bangalore. And because of any reason, if Hyderabad server goes down, the Bangalore server will automatically be up and it will take over, and that is responsible for high availability. So all the calls will be served by the Bangalore server. So something like that. So there will be automatically switch between the servers. If one server goes down, the other server will come up automatically, and that is called cluster. So cluster is created between a set of nodes for high availability, reliability, failover. If the one node goes down, the other node will come up, right? So we can have n number of nodes connected together, something like 8 node cluster, 16 node cluster, something like that, right? So there will be a clustering software that is responsible for taking care of checking which node is down, which node is up, checking for heartbeat. Heartbeat in the sense it will send a message to all the nodes and find out which node is alive, which node is down, right? So that is called high availability. High availability is nothing but making sure that the service up all the time. It's like there is no downtime. So the downtime will be less than 5 minutes in a year. So it will be up all the time almost. So that is high availability. So this is in case of servers, right? We have physical servers, we have connected them, we have software running on them, right? So in case of containers, Docker containers, how do we achieve this high availability, right? Even container can also go down because of any issue. So this can be a network issue, a memory issue, or operating system issue. So servers can crash because of any reason, right? So if server crashes, it shouldn't be like my website is down. So that is direct loss to the customer, right? So let us say you're accessing Citibank and suddenly Citibank has gone down. So that is like a transactions are stopped. That's it, like doesn't direct business impact for the bank, right? To avoid all these things, we have high availability, we have clustering softwares, right? Here also we have something called Docker Swarm that is responsible for high availability in the containers So if one container goes down, the other container will come up automatically, right? So excuse me. So if we take example of we have 3 machines, server 1, server 2, server 3, right? So we'll create cluster of these 3 servers, and these are physical servers, not VMs. Physical servers, right? All 3 physical servers. So I have one VM, server 2, I have another VM, server 1, right? So in the same way, I'll create another VM as server 3. I'm just creating another VM. So 1, 2, 3 servers I have created. So think these are not Vagrant VMs. These are actually physical servers. Assume these are physical servers, and we are going to create a cluster between these 3. So if I physically shut down one of the server also, I should be able to access the website. So what we're going to do is we have 3 servers, so we create a cluster out of 3, cluster of 3 machines. Then on the cluster, I'll set up Nginx, Nginx web server. So if I access using HTTP and the machine name :80, I should be able to access the uh, website, right? So this website should be up all the time. So what I'll do is I'll scale up and see how many containers are created, where are they created. So as I said yesterday, we created clusters of 3 machines. So it will be, first machine is called manager, the other machine is called worker 1 node, worker 2 node, right? And then we configure the web server, then we access using HTTP, and there will be containers created. And now let us say there is a high load on the website. Now I want to create multiple containers to handle the load. So we'll see how to create multiple containers, how to scale up in the sense increase your infrastructure, right? And then shut down one of the node, right? We'll shut down one of the node and see how containers are moving from that node to other node, right? We can always see how many containers are running in the node. How do we see running containers on a node?
Docker PS.
Yeah, right. So we can see how many containers running on the node. So we'll shut down the one node and see if the Docker PS command is showing the more number of containers or not, right? So this is what is high availability. I simply shutting down one node, maybe in reality, in practically, there might be some problem in the server that will go down automatically, and whether the other server will take up the load, right? So here we don't deal with worker 1 or worker 2. Everything we tell to manager. I want 10 number of containers extra. So this will take care of creating the containers. It will check whether it has to create an worker 1 or worker 2. Automatically it will create. Maybe it will create 5 on each or 6 based on the load, based on the CPU utilization, right? So this is the cluster. So there are some commands to be used.
It's load for what? Load for images or like
load for the web server, Nginx web server.
Is it if your web servers are running inside the Docker?
Yes.
And if the Dockers, you kill the Docker, and the web server will be moved to another Docker. Is that what you're saying?
Yes, container actually. So web server is running
Oh.
inside the container, and if that server goes down, that containers will move to other physical server.
That container will go to others. Okay, the whole container. I'm still a little bit confused about image and container relationship. Like, so let's say if you remove the image, the container will still there, right? In the same way, when you kill the container, image is still there or no?
Yes, image will be still there. So image is
image
like
and container, they are both separate entities, right?
Yes, they are separate.
Okay, so if you kill the Docker, kill the container, the image that we built from that container would still live, is still there, right?
Yes, yes. So container is simply like a process running on a machine.
No, what I'm trying to understand, for example, let's say you have just one Docker, right? And you have one container and you have one image, right?
Okay.
And when you kill the container, the image will go with the container as well, right? There's no other containers available to move for the image.
No, see, for the first step, what did we did? We did Docker pull. That has pulled the image to the machine. So
Container.
the image is there in the machine, right? From beginning, image is there in the machine.
Yes.
So when we create a process on top of it, that is nothing but container. So container is something like a shared process. So even if you stop the process, start the process, the image will be still there in the machine.
Okay. So basically, first you pull it, and when you say Docker run -int, it will basically running, and then you mention which image. Then that way it's going to create the container automatically and run the image inside the container, right?
Right. Yeah.
And one more thing, for example, then you push it and then you pull it. When you pull it back, right? And let's say you pull a new image from the Docker hub, right? And that image is, let's say, XYZ, right? Now you pull that image. Now, if you want to run the same image on your existing container, is it the same command like Docker run, and then you mention the image, and you want to run the recent like pull image in your existing container?
No, we cannot run that on the existing container. So to run it, then we have to stop it. Then again, we have to start another container, because container is already having an image and it is running. So if this image is new, so we have to create a new container with the new image.
Okay. No, for example, I was thinking, for example, you have a container, right? And then you create an image, right? Let's say, and that image you push to Docker Hub, right? And after you're pushing, somebody make changes to the image, right? And then you pull the same image back, right? And when you're pulling the same image back, can you run the same image on your existing container where you already made changes and you want to make more changes, or you cannot run that, or you have to create a new container for the new image?
Yeah, we have to create a new container for the new image, because the already container is already up with the image. So if you want to have a new image, we need to create if you want to have a new container, we need to create a new container with a new image.
Okay. In this case, like all the existing configurations that we already have in the container, we cannot use those, right? So
no, actually, when we are customizing the image, we do all the configurations and we stop the container and then we create the image, right? So that image has everything, all the configurations which we have done in the container are already present in the image. So that we are going to upload it to Docker Hub. So anybody can pull the image, and if they create a container out of the image, they have all
Yeah.
the changes which they have done, right?
That I understand that part, because the image is like, we did apt-get install yum or whatever. We did couple of installations, right? All
Yeah,
those installations are captured in the image, right?
right.
All those installations are also captured in the container also, right?
Yes, container also, right.
So that's what I'm saying. So for example, I already have the image and I have already all the configuration in the image and the container. So
Okay.
I want to go back into the same container where I already have, I know what I already have installed, and I want to
Okay.
add more things on top of it. Okay, you know what I mean. Okay, I know what.
Yeah,
So
got it. So let us say you have image and you have container, and the container
yeah,
you did all the customization, and you again created an image out of the container. So you have
yeah,
image and container. Now you can always
yeah.
go back to container. You can always do start and stop, and again you want to work on the same container. Yes, you can do that customization again. You can do.
Okay. So I want to use the same image that I pull after changes and go back to the same container that I created earlier and make changes there. You know what I mean?
No, that cannot be done. See, you let us
Okay.
say you have uploaded to Docker Hub, and
Yeah.
the same image someone else has taken. He created a container out of it, and again he did some more modifications. Again he pushed it to Docker Hub. So this is a second
Yes.
image. That changes you
Yes.
do not have, and that image you again pulled. So this image which you have pulled, second image, this has some more changes that you
Oh
cannot
yeah.
use for the existing container. You have to create a new
Ah.
container on top of it, right?
Okay. If there are
And
no changes, then I may be able to do it. Maybe no.
sure, right. So
Okay,
in
got you.
production, in practically what happens is every time they spin up a new container, right? Because
Okay.
spinning up a new container is very easy. It happens within few seconds. It's not like a VM, right? So where it takes a lot of
Yeah.
time to reboot, provision and all. So on the
Yeah.
fly, so along with the Jenkins, when they use this in the workflow, what they do is with a small bug fix also, with a small feature also, every time they spin up a new container.
Okay. Yeah. I see. It's like as you showed us, so it's very straightforward to just spin quickly. But
Yeah,
it was like a little bit confusing for me, image and container relationship.
yeah.
Okay, I got you. Yeah.
Okay, fine. So now we are talking about Docker Swarm. I have three machines. That is my third machine. Okay, this is my third machine. If we run three Vagrant VMs, sorry, not Docker, right? Vagrant. If we run three VMs on the laptop, it may become slow. And if we run some load, it may even become slow. Something is wrong with the network. Okay, let us first start with two VMs. So this is server 2, this is server 1. So I'll make this as manager. So Docker Swarm manager. So this I'll make as worker 1. This is worker 1. This is manager, and this is the third node. Let this come up. So before that, let us see some commands to configure the cluster. So first we need to log into the manager and then execute a command. So workers are like slaves. Manager is like a manager. So manager delegates the work and workers perform the actual task. Okay. So here manager also does the work because the containers also will run on the manager. So there are some prerequisites to create the cluster. So Docker version should be 1.1.2, more than 1.1.2, and they should be communicating with each other. They should be in the same network, and some ports should be open. So by default, they'll be open. Okay. So I'm initializing the cluster on the manager. So this is the command: Docker swarm init listen address. Let me paste here. So create cluster of 3 machines on manager. Docker swarm init listen on address, this address, and advertise address, and this is the manager address. The next one is the worker address. Okay. Oh, sorry, this both are manager address. So let me get the manager address. Okay, so this is my address. So I'll use the same address. So Docker swarm init, and then this address on port 2377. Okay, and this is the address. So I'm creating a manager. This is the first command to set up Docker swarm. I have the manager node and I'm setting up on the manager node, right?
So what is advertise address? What is the difference? Listen and advertise.
Yeah, I'll tell that. So Docker ls.
I think it is similar to broadcast. It's basically broadcasting the IP address to others.
So basically what happens is this on this address manager will start listening on port 2377. So this will start broadcasting this address. So it will generate a token. So this token should be used on the other slaves to connect to this manager, right? So exactly syntax wise, maybe I can check a help page. What exactly is advertise address? So this is the convention we have to follow. So basically give manager address and also give advertise address. Yeah, probably that is the case. Like we broadcast this address to other slaves.
I think it's broadcasting, so anybody can on the network can see that address, right?
Yeah.
This manager is the IP that you mentioned. Is the IP for the server?
Yeah, IP of the manager.
From where you got that IP?
Advertised address format. This is the current machine's IP. This machine's IP. I mean, if I do if config on this machine, I get an address, right? So that address I am using to generate a token, right? So I am currently on the manager, Docker manager. I'm initializing the Docker. I'm initializing the cluster. So basically this is like creating a single node cluster. Then we add the nodes to this cluster to form a Docker worker nodes. This is the manager. I'm just initializing the Docker swarm on this node, and this generated a key. So this key I'll use to form a cluster.
Okay.
So this is directly telling to add a worker to this nodes, to this swarm, run the following
Okay.
command. So I just need to
So,
go there and execute this command on the
okay. On
worker
the
node.
slave, on the
Yeah,
on the Docker,
on the worker nodes. So
the worker nodes, yeah. So
this
basically,
will
Docker is using the server IP to
communicate.
because
Yeah,
I remember this Docker has its own IP also, right? Containers.
right. Yes, the same IP it's using. Oh, you mean no? This is not in
Container.
container level. This is in the machine level because the communication always has to be on the physical server level. Because if one physical server goes down, other has to come up, right? So that is the
Okay.
reason why it is using the IP address of the machine and not the container IP. So here we are not
Okay.
creating cluster between the containers, but we are creating containers cluster between the machines.
Okay. Gotcha. Is it always 2377?
This is always 23/7. So next is I need to execute this on worker nodes. I have 5 worker nodes. I need to execute the same command on all 5 worker nodes. So that will create a cluster of Docker machines. Okay. So let
Any
me copy
prerequisites?
this.
Just install Docker. That's it.
Yes, we need to install the Docker, and we need to have communication, and we need to have what is that Docker version greater than 1.1.2 because this feature is introduced from 1.1.2.
Okay.
Okay, so I'll copy the same command and I'll go to the worker node, to my worker node 1 and execute Docker swarm join unknown shorthand flag -t in the token. Something is wrong with
Dash
syntax.
token, I think.
Token, it has given the command, right? As it is, I copied.
I think you remove the two.
Oh, cannot contain to container. Is it running? Let me see. Service Docker status. Okay, it is not running. Let me start it. It started. Okay, this node joined the swarm as a worker node. Now if I go here and execute Docker node ls, so this will show both the nodes ready, active. So this is the leader. This is nothing but the manager, and this is the slave. So we have both the nodes available in the cluster, right? Let me see, the third node is up. Something is wrong with my cluster. Let me create another one.
Which are you running Ubuntu or which one?
This is CentOS.
Windows.
Okay, so we created manager, we created worker 1, and we're waiting for the worker 2 to up. Then I execute the same command on worker 2. That should create a cluster of 3 nodes. Okay. I didn't copy it here. Okay. Let me copy. So this on worker nodes we executed this command, on manager we executed this command. That will generate a token. This will add worker nodes to manager. Next step is to configure the Nginx server, sorry. Then we need to scale up. Then we need to check high availability. So there is a command to run service on the node. So Docker service create name with the website publish 8080. So this is a container image available on the Docker Hub that if I download and use it, this is like something like we used in case of a project we used it, right? What is that? While creating Jenkins integration, we downloaded Game of Life, right? So it's readily available. And we have customized our own image, Ubuntu Python, right? And if you upload it to the repository, like that, someone has uploaded this web server, the image, this we can directly use. Okay, so this will create Nginx server on the machine, right? So I'll just use this Docker pull and this command to create a image in my machine. Okay, then using Docker service, we configure this service on top of the container, sorry, on top of the cluster, right? So Docker service is the command to configure the web server. So we just do Docker pull and this command. This will download the image, pulls the image to local machine. So this is nothing but my manager. Right. So on manager, I'll have my image. So this is worker 1. This is my manager. So I'll go here and say Docker pull pull the image. So this image has web server configured in it, and if I create a container out of this, that container will have the web server already configured, right? But if I want to create the container on the cluster manually, I need to tell on which node I need to create. But here, manager will manage it. I just say create 10 containers. So it will automatically create on the nodes. Based on the number of nodes, it will create. Something is wrong with the network configuration. Okay, fine. Let us go to this node. Let us run this Docker service create. Now, if I say Docker PS, these are the running containers. There is nothing like we haven't created any container with this image. What is the image? Site Docker Swarm walkthrough. We didn't create this container, right? This container is not running. So here also I have nothing, right? No container is running on the worker 1 node. So what I'll do is I'll create a service. So Docker then copy properly. Docker service create name website, or we'll say Nginx website, Nginx website, publish on port 8080, and this is the image from where it has to create the container. So I'll just copy this command and use it on the manager.
Is it the service is primarily to create websites?
Yes.
Okay.
So it started creating a container. So this is the container which is created. Let us see if it has done something on here. No, it has not yet created on the worker one yet. So there is a single container created on the manager node. Now can I access this using IP address of the manager node? What is the IP address of the manager? We have IP here. Let us see on the port 80, it has to show a web page, right?
Yes, it should showing 80, but we haven't done the port forwarding yet.
Publish 8080 we have done, right? That is equal to port forwarding. So we don't have to again create, because while creating the service itself, we have told to use 8080.
Okay, okay.
Okay. So this is running, Docker Swarm is running on the manager. Let us see if I have something Docker PS. So there is no container running. What is the IP address? This is the IP address. See, if you see, I just created a container is created on the manager, but if I access worker node also, I'm able to access the website. So how is this possible? There is nothing running on the worker node, right? There is no web server running on the worker node, but if I still, there is no container running on the worker node. If I access using the IP address of the worker one node, I'm still able to access the website. How is this possible? This is possible because of cluster. So there is a internal networking setup between the manager node and worker nodes. So you access any node, the load will be equally distributed between the cluster nodes, right? So that is called load balancing. So Docker Swarm also takes care of the load balancing, high availability, reliability, failover, and load balancing. So based on the incoming.
I have a question.
Yeah.
Here, the web server is running on manager node, right?
Right.
But load is taking on manager node, not on worker node.
Right. So what I meant to say is the internal networking is set up. Even if we access the slave, the agent where the container is not running, it is still able to redirect the traffic to the master, right?
Yeah. Mm-hmm.
So currently we don't have any load, but if we have high load, the incoming web traffic will be redirected to the node based on the load.
Okay. If it is a high load, is there any new containers going to start on a worker node?
Yes, it will be started. I mean, it will not automatically started, but if there is load which is going to high, we need to scale up.
Oh,
Okay, so that we have something called Docker service update replicas. Let us say we give like this. See now Docker PS grep for 6 and WC-L. So this will give me number of containers running with the web server, right? So if I say Docker PS 6 ID is, this is our container. So how many containers are there with that service? WC- will give line count. So only one service is there. If I execute the same command on the worker node, what will be the output? Docker PS grep for 6 and WC-L. 0, because there is no container running. Now what I'll do is I'll just I'll scale the number of containers to, let us say, 10. And what is the server? The server name I have given is engine index website, right? So now we'll see whether it will create multiple containers. You can see using this command wc-l. See, there are 5 containers created, and here it is not yet created. So I have asked it to create 10 containers. Let us see on which node it will create. So here 5, here, two, 5. See, I just asked it to create 10 containers. I did not tell to create on the worker node, create on the manager, right? So it has created 5 containers on the worker 1 node, created 5 containers on the manager. Now if I do docker ps, I have all my containers created, right? These are 5 containers running. Actually, I did not touch my worker node after creating the cluster, but automatically the containers are created on the worker 1 node, right? So this is what is load balancing, right? So you ask to create n number of clusters. So it will check which node is free. So based on that load, it will distribute the number of containers, right? So manager does that job. So if I say docker ps, there are 5 containers created, right? So to handle the incoming web traffic. So this way we can scale up to n number of containers. So based on the load. Is this clear?
Okay, can we move that that website container to the slave node manually?
Manually, I don't know if there is any option. Because
Let's say we have some maintenance going on the master, right? And we want to bring down the master, and we want to move all the containers to the second node.
There is a command called leave, docker swarm leave. So this will leave the, this is for only worker nodes, workers only. So if I say leave, this will come out of the cluster and automatically those containers will be moved to the manager node. So we'll try that. So now I have 5 containers.
This is okay. So I think the best is to not to create containers on the master, but always contain on the worker, right?
Yeah. So basically, this will manager also will share the load here. Okay.
Because that leave thing is only for workers only, but not for managers. So I think we cannot the containers on the master cannot be leave. So it's going to be stay there unless it's going to be go down.
Right. Yes.
Okay. Maybe we can try to just shut it down and see how it goes.
Yeah, that's what. Either leave or shut it down. Anything is fine. So what we'll do is we shut it down. We'll say vagrant down. It will automatically come down, right? So I'll come
go
out
to
and I'll say,
go to master, not like
not master. I'll do it on the worker. Okay. Vagrant.
Worker. How about if master goes down?
Yeah, if master goes down, let us say there are multiple nodes. If master goes down, we have to manually switch other node as the master. Something like we need to promote the slave as the master.
That is one thing, but what happens to the containers on the master?
Yeah, containers will move, but there is also a way to configure 2 masters using Docker Swarm, so that if one master goes down,
I think that we have to configure 2 masters maybe.
Yeah, 2 masters you have to configure. I'll say vagrant halt on this machine, so all the containers should move to the other machine, right? Actually, if I have 3 machines, I would have shown you, but somehow this machine has some problem. So this is my vagrant 2. Sorry, this is my master. So let us see, will it create any containers here once this goes down? Once this completely goes down and it detects that Docker node ls will show whether node is up or running, up or down. See, it shows, actually it continuously pings the slaves, all the slaves, In case we have only here we have only two slaves, but if you have multiple slaves also, it will show the status as down. That indicates that it always pings, it checks the heartbeat of the slaves, and if it finds that it is not responding, then it will make the node as down. See, this node is down, means the second node which we have done shutdown halt is down. Now let us see if it starts moving the containers. See, now all the containers are running on the master. Since this node is down, it has moved all the containers to master. So if I have, let us say, another node, again the traffic will be equally distributed. So 5 containers will be created on the third slave. If I have multiple nodes, again the containers will be distributed between the nodes. That is like load balancing. This is like high availability. Even if the machine is going down, all the containers are moved, failed over to the manager. Right? Is this clear?
Yes.
So this is to scale up. I'll send this. And the Docker node is to check the status. Check the status. What else? Heartbeat. We'll check whether the particular node is active or down. Okay. Now let us see if the website is still up. It should be up because we have the manager. Yes, it is up.
Is it going to be still up using the slave IP that is down?
Obviously, it won't be because it cannot route, right? The machine itself is down.
I think it should work maybe.
So see, first initially where this request will go, this will go to the slave. So
Yes.
if this, from the slave, it should be redirected to master. So slave itself is down, it cannot do anything, right? So there is an internal networking setup, but if this will not work, unless the same machine has 2 IPs, right?
No, if it is a floating IP,
Yeah, if it is a floating IP, it works. But see here, we are directly trying to contact the machine which is down. So even if there is an internal networking setup, I cannot reach this machine. So obviously this will be down, right?
So basically, it means the website should be resolving to the master Docker machine, right?
Right. So what happens is actually in practical world, so there will be something called, if you talk about AWS or something, there will be something called load balancer. So that is actually a software that redirects the traffic to instances, different instances running on the AWS. So one load balancer can have multiple machines. So load balancer is just like a traffic constable. He just redirects the traffic to different instances based on the load. So in the similar way, here also we need to have one load balancer configured that will actually redirect the traffic to. So basically we need to have a DNS entry for the master. So that entry we give it to the customers or anybody, something like google.com. So that's a DNS entry. So that maybe if it is running on the containers, that will redirect the traffic based on the load, right? So it will redirect it to different slaves and we can scale up, and if the machine goes down, the containers will be moved. So that is the basic Docker Swarm concept, right?
Yeah, I think the load balancer, even the load balancer, for example, you have Netscaler as a load balancer. So Netscaler has a virtual IP, and that virtual IP is NAT to all Docker's master and slaves. And it load balance between doing the round robin, whichever is available, right? So
Right.
your virtual IP that is defined on your load balancer would be resolving to the DNS. So at the back end, it's natting to all Docker's machines. So any Docker's goes down, it do the round robin, it goes to the other IP. So it's resolving the DNS entry is resolving to the virtual IP on the load balancer and not to the master IP actually for load balancer part.
So here also, if you see, if we have master IP and if we try to access master IP multiple times, and maybe if we change this file in different nodes indifferently, we'll find out where exactly the request is going to, right? So even if we hit the master, let us say multiple time, first time it is going to master, second time where is it going, that we'll find out. If we give something like a node name in the, so this is like something like index.html. So master also will redirect the load. So something like if I access 2-3 times, I'll come to the, let us say I give the host name here. For the first time it will hit the master, second time it may hit the slave. So that is what is load balancing, right? So master itself does the load balancing.
Okay, I think in this case we can just give the master IP, right? We don't have to give the virtual IP here.
Right. So it is
Even if the let's say master has 5 slaves, let's say, and 3 slaves are down, it will go to the live slave if it has load balancer, not to the dead one, right?
Right. So here, in case of Docker, load balancer is inbuilt in case of Docker Swarm. So we don't have to have separate load balancer. Only the master IP we give as a, we make a DNS entry and give it to the customer. So when they access, it is the manager's responsibility to share the load between the slaves, active slaves. Right, you're right. Yeah, it will distribute between the active slaves. But in case of VMs, the AWS VMs, we need to have a load balancer that does the routing part. Right?
Okay. Yes. Is the master is checking the heartbeats for the slaves?
Yes, it also checks the heartbeat, because we can see here which node is down, which node is up, based on the something like a ping.
Ping, right? Okay. Ping request maybe.
Yeah. So I mean, because the Docker daemon is running on all the machines, it communicates to the slave nodes using the Docker daemon.
Yeah.
Okay. So we'll stop here, or we'll start a new topic. So so this is the clustering concept of Docker Swarm that will achieve high availability, failover, scalability, right? Reliability as well. If one of the machine goes down, containers will be moved. So like that, there are many clustering services which are coming up in the market, right? So we have something called Mesos, DCOS, Google Kubernetes, right? And these all are actually the same. They act as the same way. We create a cluster on multiple nodes, and the load balancing and high availability achieved using these softwares. Google Kubernetes also used widely in the market, and there is also something called OpenShift. This is also like a Docker service. Using this also we can achieve.
Yeah, Kubernetes is very popular. Like Kubernetes, a lot of people are using.
Yeah, Kubernetes, Mesos, DCOS, all these are really getting popular in the real world.
So this is like open. So this is an open source load balancer, free of course.
Yes, all are open source. We can.
Okay. Everything is getting over open source.
Right. Yeah.
Free. Everything is getting free.
So we have AWS, Chef, Puppet, and Python left for the course. So AWS may take 5 to 7 classes, Chef another 4 to 5 classes, Puppet another 4 classes, and Python 2 classes. So this is what is the schedule left for us. When did we start the course? Is it 1 month?
Is it Python? Is we gonna learn the whole language Python? Or?
Not completely, but so basically we start with the syntax, indentation, the data types, the modules, functions, and then so basically we'll see the dictionaries, tuples, and all that stuff. So kind of basic Python.
Okay.
And Santosh, how we can use Python in DevOps, the scripting perspective?
Yeah, good question. So AWS
So,
we have.
those we still have to cover Kubernetes, no?
No, Kubernetes is not part of the course. So we covered Swarm. So Kubernetes is kind of left optional. So Docker, Swarm is the one which we covered. Anyway, we'll try if we have time at the end of the course, we'll cover that as well.
Oh, okay, because it was mentioned on the course curriculum that Kubernetes is there, so that's why I was asking.
In the this thing agenda, or I mean something
In
is
the on the site on the course curriculum, it shows Kubernetes. If you go like on the visual, they actually mentioned too many things actually. They mentioned like the whole book there.
And actually, there are multiple trainers. I don't know which one you're referring to. Maybe you can send me a link.
If you go to this visual path site, and if you go to DevOps and you go to course curriculum, this is where they mention Kubernetes as well, and they mention many others as well actually.
Yeah, so that will be again 60 days or 90 days course.
Yeah, I agree with you. I agree with you.
Yeah, I mean there are multiple courses actually. So there is something like.
But DevOps is only one course there. Only there's
in DevOps also we have something like a 45 days course, and there is something like one-to-one system course that takes around 3 to 4 months. So there, probably I don't know which course you're checking. Anyway, I'll take a look. So in coming to your question, where do we use Python? So in Jenkins or in AWS or anywhere to automate the things, sometimes shell scripting is not enough to perform some tasks. So there we use Python, right? And there is something called in AWS, we need to write some scripts to communicate to the instances. So something called Boto framework, right? This Boto is a Python module. Sorry. So there it will be useful. So mostly when we are dealing with the cloud, we need to perform some tasks. So there Python will be useful. Okay.
Yeah, about the cloud, like I don't know, like I don't know if you can cover anything with the VM moves, like moving the VMs to AWS. Is I mean, I'm just. Do you have any experience with the cloud, like cloud deployment or cloud moving the VMs in the cloud using the open source any other tool? Or I'm looking to VMware or Azure or anything.
See, actually, we use a lot of cloud. I mean, our infrastructure is entire cloud only. But migration part, yes, I don't have any experience. Maybe moving the VMs or something.
Also, one more thing about AWS. It's all Linux-based cloud, right? They have all the base hypervisor is a Linux, right?
Yes, they have all Linux-based.
What kind of hypervisor is it?
I mean, that is not disclosed outside. Maybe they use KVM, or so mostly they use the x86 machines, the Intel x86 machines. So I mean, it's not. I think they use multiple hypervisors. Exactly. I don't think it's exposed outside. The KVM is kernel-based virtual machine, open source. Maybe they use VMware ESX a lot.
Okay.
Yeah, I think what else they use? Hyper-V. I think they may use. Maybe they are using this Microsoft virtual server as well. I think that's not exposed outside. It's all.
Yeah. Okay. Yes. Just like the Microsoft is using Azure anyway, so they're using Microsoft.
Right. Yeah.
In AWS, it's not clear like what they're using.
Yeah. So it's all like I mean, we just get the service. We don't know what internally, what servers they're using, what's the hypervisor, what is the clustering technology. They have a lot of end-to-end automation in place, right? So everything it will take care. So we'll stop here. Thank you. Bye-bye.